Hello there, this is Anthony Johnson, and this is another episode of SQL Interview Prep. The interviewer asks you, what is an index? An index is a structure that is created to help speed up retrieval of data from a table and or database, or from a table, because indexes are objects of a database, but they are typically placed on tables to speed up the retrieval of data. You have your non-cluster index and you have your cluster index. You only have one clustered index on a table because it physically is stored, it physically reorders the order of the data on the table. And also on disk, that is physically stored on the disk that way. Non-cluster indexes typically use pointers or data pages to point to where the data is actually stored. So it's not typically, it doesn't reorder the data in the table, but it does help on retrieval. So if we look on the screen here, you will see that we have 8 values. We're focused primarily on our ID column. And we see that our IDs could be in order, honestly. So let's fix that. Create clustered index. Then we give it a name, class ID IDX on our table name here. We're gonna just place a DB on front of it. Open and close parentheses, ID, then we'll give it an ascending order. And now let's execute that. It was successful. Let's Control-Shift-R to refresh. Now let's check out our table. Looky there. Our ID column is in chronological order, and of course it's missing the IDs, but based off the values, the data that was provided, this is in the chronological order, correct chronological order. So that is a cluster index. So now let's just run a query. We're gonna actually include the actual plan. So let's do select from. It's just a simple query, DBL. And of course, it's not a massive table where it will make a huge difference. Where it will actually have to pick from between a table scan and an index seek, or an index scan and an index seek. So let's see what we get back. So this is a part of what the index is, part of the retrieval process. It's primarily focused on the where clause. We have an index on our ID column. So we're going to say where ID, because this is the point of referencing our index. This is how we trigger index search, or index seek, I should say. If you hear noise in the background, that's definitely my daughter. She's crying, and that's it's just that time. She's about to be 2, so that's neither here nor there. We'll say where ID equals 11. And let's just see how the database engine processed that. Okay, took 4 seconds, but let's see what we get back here. Okay, use the cluster index seek, which I expected because we literally was searching based off of the actual ID, which we have a cluster index on. Okay, so now based off that same table, we can only have one cluster ID on there. So based off this same table, let's actually create a non-clustered index. Okay, so what we're gonna do here is, so you see, it's gonna kind of be optimized, and it might be a filter index. You have your filter indexes, you have your cluster index, your non-cluster index, your unique indexes, your unique cluster, your unique non-cluster. There's a plethora of indexes that you can use. Typically, it's solely used for speed up retrieval. Inserts, updates, and deletes actually with indexes on the table actually harm you. So you may have to actually drop those indexes and rebuild them, disable them, and then rebuild them. So that's an option there. So let's actually create a non-cluster index. Then I'll send you guys on. So typically, like I said, you have your cluster, your non-cluster. Those are the 2 main cluster indexes typically that the interviewer will be seeking, and actually what they do. So create non-clustered index, we'll just say non-IDX on. We're gonna take our table name again. The syntax is very similar. On date, or not date, actually contract expiration date. Contract X date. And so we want to see the one that's closest to us. So that the ones that's going to end in 2024. So we're going to actually add a filter to this. So it'll say where. Just copy this name here. I'm going to say where contract date equals, and this is what I meant about the optimized part. Shucks, I hate that I have to do this, but just for time and representation sakes, we're going to say equals 2024. So essentially what we want here is we want to be able to filter speed retrievals based off of the year. We want to have the current year contract expiration date contracts pop up first, or faster retrieval on those more than anything. Okay, so it doesn't like that. So what we're going to do is we'll say greater than 2023 12/31 and place it here, less than or equal to 2024 12/31. Okay. Well, actually, we won't do that. We'll just say less than or equal to. Yep, that's good. That works perfect, actually. Okay, so we created that. All right, so now let's add an additional filter. Select all from BBO.clients, detail where contract expiration date is less than or equal to 2024 12/31. Let's see what we get back here. Okay, and as you can see, it literally was a blink of an eye, 0 seconds. And now let's see what we get here. Okay, so we have a cluster index scan here, which is fine, but it did actually use the index, which is what we were actually seeking. And like I said, it was literally a blink of an eye. So for a quick recap, what is an index? An index is a structure that can be placed on a table to help speed up retrieval of data. You have your clustered index. It can only be one cluster index per table. You have your non-cluster index. You can have 999 per table. So you can have literally 999 non-cluster indexes per table, but only one cluster index per table. Clustered index, it physically reorders data in the table, and it is stored in the data pages physically. With a non-cluster index, you have pointers pointing to the data pages where the actual data resides. Non-cluster indexes does not physically reorder data, but it does help speed up retrieval of data. I hope this was helpful. I hope you guys have a blessed day, and bye-bye.